Hello students, today our topic is normalization. What is normalization? The process of structuring data in a database. That is known as normalization. So it means the arrangement of data. So what are the advantages of normalization? It avoids data redundancy and helps to attain data integrity. Data redundancy means duplication of data. It's a duplication of data. That means same data in different places. So what happened? Wastage of memory. It results in wastage of memory. So here, the normalization helps to attain data integrity. Data integrity means if we update a data in one table, that will reflect. That means that change will reflect in every tables in that database. So data integrity is also very important, and this normalization helps to attain data integrity. So for a in a database, we want to normalize, we need to apply 3 types of normalization: 1NF, 2NF, and 3NF. So without any normalization, that is 0NF, that is unnormalized form. So this unnormalized form, it's a flat file. We can see it's a flat file also. So there are different drawbacks for this flat file. Means wastage of memory, data redundancy, that is due to data redundancy because more data. So it's very difficult to find search a data problem with data integrity problem is there. Okay, so lots of problems are there. So here it is a flat file that is unnormalized form. So here there we can see repeated group of data. A repeated group of data means storage of wastage of memory. So that is redundant data is there, and it is non-atomic. Non-atomic means we can see all data in one set. For example, name. So it contains all first name, last name, middle name, last name, all in one place as one data. That is non-atomic. So this type of data is non-atomic. So that is the problem in the case of unnormalized form. For example, in the case of a car brand, BMW Black Active Hybrid T. So BMW is a brand name, Black is a color, Active Hybrid is a model name. So if BMW Black Active Hybrid, if we store all as one data, then what happened? That is non-atomic. So we need to split this data into brand, separate brand, then color, separate data, model and model separate data. So that is atomic. So if all this data, if we can see in as one that is non-atomic. So that's a flat file. So it's an unnormalized form. That is in unnormalized form. So forename and surname or middle name and last name in same field. So if all data are in the same field, it is non-atomic. So that will decrease the efficiency of database. So it's a flat file. Okay. So what are the problems with data redundancy, duplication of data? One of the main problem is wastage of memory and no data integrity. So here data is inconsistent, means if we update a data in one place, that data will not update in other tables. And as a result, different values in different tables. So wrong information. So we can say inconsistent, data is inconsistent. So if there is no data integrity, there's a problem with flat file, which is in unnormalized form. So if you want to normalize a file, then first we need to learn what is 1NF. We need to convert that into 1NF. So these are the methods for normalization. Then after 1NF, then 2NF, second normal form, then 3NF. There are mainly 3 normal forms, mainly, okay? The basic normal forms are 3. So in the case of 1NF, first normal form, these are the 3 points. First point is to be a table or a set of data, if it is in 1NF, then that table needs a unique primary key. We need to set a unique primary key. Primary key means like ID number, passport number, like that, admission number, car registration number. So it's unique for each and every entity, yeah, for each and every. For example, the case of student ID, it's unique for each and every student. Passport number, each and every citizen, yeah, it's unique. So a unique key, it's a we need to set some primary key which is unique. So that primary key is used to distinguish other rows in that table. That's the use of primary key. So we can identify a row or record from other records by using this primary key, that is which is unique. Then all fields must contain atomic. Yeah, we need to split. For example, if our first name, middle name, last name, or surname all are in one field, then we need to split it into different fields. First name, surname, middle name, like that. Or like car model, color, brand. Okay. So we need to split like this. Then no repeating groups of data. If repeating groups of data are there, we need to remove that. So we need to what these 3 points are very important in the case of 1NF. For example, here this table, this is a bill order table. Okay, this is the order table. So here the customer purchased different products from a shop. So this is a bill, actually order table bill. So order date is there, customer ID, customer name, customer address, and we can see some extra data with indentation space. Look, that is product code, distribution quantity, price. What's the meaning of this? These 4 fields are repeating because the customer need to buy more than one product. So he need to buy more than one product. So this product code changes, yeah, for each and every product. So product code, description, quantity, and price varies. So in one bill, there are lots of products. The customer need to purchase lots of products, but one bill for one customer. So these informations are not repeating, but these 4 data are repeating. So that's why here indentation is there. Okay. So according to 1NF, what are the basic points in 1NF? A unique key, it should be a unique, there is a unique key, primary key. All fields must contain atomic and non-repeating. So here we can see repeating. Product code, description, quantity, price are repeating. So we need to remove this. So this is not in 1NF. First we need to achieve 1NF. Then only we can attain what? 2NF, then 3NF, like that, in order. So we need to remove this because this is not in 1NF. So here we can split this table like this. So a unique key, we need to specify one unique key, that is in 1NF. To be in 1NF, table needs a unique key, that is, here we can say order number. Order, we can say some order number, that is we can set some that as a primary key, unique key. It's a unique key, order number. Okay. So we need to give some new field. That field is not here. So we can assign a new field like order number. Then this customer ID, customer name. Customer name means it is what? Customer name. It is atomic. It's not. Is it as atomic data? Customer name and customer address. We need to make it atomic. It's not. It is non-atomic. Customer name and customer address, because customer name means we need to split it into first name, surname, like that. Then customer address, we need to split into address 1, address 2, zip code, like that. Yeah. So we need to split. That is not in atomic. So it's non-atomic. So we need to change it to atomic. That's the next property in the case of 1NF. Then we need to remove the repeating groups of data. This one. So we can change the table like this. So the order table becomes this is order table name. Then inside bracket we can represent each and every field. Order number. Why here there it's underline? This is a primary key. That's why underline. Order number is a primary key which is unique for each and every record. Then order date, customer ID. Then we need to split this customer name into customer for name, customer forename, then what next, customer surname, and then customer address. We need to split it into customer address 1, address 2, customer address 3, customer zip code. So now this customer name and address, they are atomic. Okay, they are atomic. So we can attain 1NF. So here 1NF is okay. Then next one, we need to remove this data, product code, description, quantity, and price. We need to split from this table, and we need to create a new table. That's order line table. So it consists of product code, description, quantity, price. Product code, description, quantity, and price, and we need to link these two tables. Yeah, some link is necessary. So we can use this primary key in order table, order number here, and this is the foreign key in order line. So order number, actually it is a primary key of order table, other table. So we can say it's a foreign key. Okay, and other values, fields are product code, description, quantity, and price. Yeah, product code, description, quantity, and price. So here actually this is a foreign key, order number in order line. So we need to use set some primary key. So product code and order number combined, we can say, okay, it is a compound key. We can set it as a compound key because more than one fields are there. Order number is a primary key. Sorry, it's not a primary, it's a foreign key plus some other key, that is product code. We can say product code. So here order number is retained in the order line table. It's a foreign key, it's a foreign key, but this is not unique. So we cannot use it as a primary key. So we need to combine. We can combine this foreign key with other fields. Then we can make it unique. So we can say order number plus product code. We can say it's a compound key. So now this table, it splits into two different tables, order table and order line. So this is in 1NF. First 1NF. Okay. So here we can see a unique key is there. Yeah, order number is there. Then atomic, all are atomic because we split the customer name into customer surname, customer address 1, address 2. Sorry, customer address. Yeah. Then customer name into customer forename and customer surname. So they are all atomic. Okay, they are not non-atomic. They are all atomic. So we've this second point is okay. Then last one, no repeating groups. So here repeating groups are there, was there before, product code, description, quantity, and price, but we split it into another table. So this third point is also okay. Now repeating groups of data. So repeating groups of data we split. Yeah, we took out from that the first table and we create a new table, that is order line table, and we need to set some primary key here also, but primary key is not possible here. So we can combine two different fields and we can say it's a compound key, that is order number. We need to take it from this order table. Why? Because it is very important to create a link between this order and order line table. That's why order number is taken as a foreign key here. Okay, so we can make a connection between these two tables. Then the second normal form, 2NF. So in 2NF, second normal form, it must have no partial key dependency. That means partial, not fully. Partial means no non-key fields. Non-key fields, other keys, other than key fields, other than compound key or primary key, like that. Yeah, foreign key, or that is known as non-key fields. No non-key fields can be dependent upon part of compound key. Part of compound key means it's partial. So it's partial, not fully. It's a part of. Part of means here there are two fields. Yeah, this is a compound key, order number, product code. So these are non-key fields here, decision, non-key field, quantity, price. But here in this order table, there is no compound key. So no problem here in the case of 2NF. Okay, so we can say 2NF. Now partial key dependency, now non-key fields can dependent upon part of compound key. So if compound key is present, then only we need to check for what 2NF. Okay, we need to check for 2NF. Understand? So here in the second normal form, must have no partial key dependencies. That means, this means no non-key fields can be dependent upon part of a primary key. So that means we can apply these tables with compound keys only, because they are the only tables that can have partial keys. Partial key means it's for only compound keys. Okay. So that means here, in this case, we can say order here, order line, order number, product code, both are common keys. So there's a problem with here. Look, this description, quantity, price, they are non-key fields. So we can see here. So order line contains only partial key. No partial key is in order table. So we need to consider only order line for 2NF. Actually, quantity, description, and price. Not quantity, only description and price, both are dependent upon product code. Yeah, because when product code changes, item change, the price also change. So these non-key fields, description and price are dependent on partial key. This partial key means a part of compound key. Yeah, this is a compound key both, but the partial key dependency means a part, only product code, not in the case of order number, only product code. Product code depends upon description and price. So this is not in 2NF. So what we need to do, we need to split this into take out. So we need to create a new table, product table, and we need to take out this description and price from this, because description and price depend upon product code, and product code also we can take out outside, and we can create a new table. So product code, description and price. Description and price depends upon product code. So we need to make it as a new table. So now there is a new table. And in order line table, what are the remaining fields? Order number is there. Product code is needed. Why? Because there should be a link between the product new table and this order line. That's why. So here product code is the primary key in product table, and here product code is it's a foreign key actually. Okay, it's a foreign key here. And order number is already there, yeah, in the case of order table, from order table. Okay, this is actually in order line. Now order number is a foreign key because order number is here, and product code is also a foreign key. So two foreign keys are there. This product code is foreign key. Why? Because here our new table in product, in this table, product code is the primary key. That's why. So this is a new table. The product code field is retained in the order line table as a foreign key, because it is still necessary to know which products were ordered. So so now there are three tables. Yeah, first table is order table, second table is product table, and third is order line. So these are the table fields. So what's the change now? Here the change is from order line we remove product code, quantity and price, and we make a new table, product table, because quantity and price dependent upon product code, which is a partial key in this compound key. Okay, that's why we removed. Okay, so now these tables are in 2NF, second normal form. Then what is 3NF? Now we need to learn 3NF. 3NF, third normal form, means must have no non-key dependency. No non-key dependency. That means here no dependency between non-key fields and partial key. Yeah, compound key, that's a partial key. The part of the compound key, that is partial key. But here we need to consider only non-key fields. Non-key. We need not want to consider key fields. only we need to compare, check non-key fields, which are not part of primary key or is not a foreign key or common key, nothing. So we need to consider only non-key fields. So must have no non-key dependency. If any non-key dependencies are there, then we need to remove. We need to take out those fields and we need to create a new table. That means there should be no fields that are dependent upon another field that is not a key, primary key or any keys, compound key or nothing. Okay, so only we need to compare between non-key fields. So here in this case, the case of 3NF, okay, in 3NF it must have no non-key dependency. So here in the case here, order table. So now our tables are like this: order table, this is order table, product table, and order line table. Here distribution and price are non-key fields, so no dependency between this. Here only one non-key field, others are some key fields. Yeah, so no problem with product and order line. But in the case of order table, you can see some there are lots of non-key fields like order date, customer. So here there is only one primary key. Other fields are non-key fields: order date, customer ID, customer phone name, surname, address, one, all this. Okay, so we can see here this non-key fields: customer phone name, customer surname, customer address 1, address 2, customer address 3, customer zip code, all are dependent, all are non-key fields. All are dependent upon this customer ID. Customer ID is also another non-key field. So now this is not in 3NF. So we need to remove this data tables, fields from this table. Okay, so we can make a new table called customer table, and we can place all these fields here: customer ID, custom for name, surname, address 1, address 2, address 3, zip code, because these non-key fields depend upon another non-key field, that is customer ID. That's why we split. So this is here this is not in 3NF, so we need to remove this, and we can make it as a 3NF in 3NF. So customer table now contains customer ID, phone name, surname, address, and address, zip code. Okay, so this is now in 3NF. So customer ID here we can say it has a primary key. Okay, customer ID is a primary key here. Customer ID is the primary key here. And what is the case of order table here? Look, order table is this, it's reduced. Yeah, fields are very less now. In order table, what are the fields left? Order number is there, yes. Order date is there. And here in now new table, customer ID is the primary key. So we need to make a link between this customer and the old order table, order table. So we can make this, we can take this customer ID here. We can take this customer ID here as a foreign key. So we can make a link between this order table and customer table. Okay, so here in order table, the order number is the primary key. There are two non-key fields, and one no, this is not non-key. This is a foreign key actually here. What? Customer ID, because this customer ID is the primary key in another table, that is customer table. So in customer table, customer ID is the primary key, and other fields are non-key fields. So this is now in, these tables are now in 3NF. So these tables are all tables are in now 1NF, 2NF, and in 3NF. So that is the, this is the process of normalization. So we need to learn these points. These points are very important. Okay, thank you.